Now, in the real world, everything's not perfect, and not all alkanes are going to be straight chains. We can certainly have branching in them, and this is very, very common. So let's take a look at butane, for example. Butane, C4H10. And what butane is, it's one of the ones we learned that is a straight chain, and we have 4 carbons. But what you can imagine is if you don't think about the name and you just think about this molecular formula and you're trying to draw a structure, what if you decided to draw a chain of 3 carbons and put the 4th carbon attached at the middle? If you draw in all the hydrogen and count up the atoms, it's still C4H10. But it's not butane. Because butane is the name for the straight chain. So what do we call this molecule? This one happens to be isobutane. And what the iso means, it's short for isomer. And it's an isomer of the butane structure. So let's define isomers. The definition of isomers is different compounds that have the same molecular formula. And that's what we have here. We have 2 different compounds. Although they have the same formula, they're going to have different chemical and physical properties. Now, we're going to learn some different types of isomers throughout the course of the semester. This first type that we see here, these are actually called constitutional isomers. And think of constitutional isomers as a subclass of the broader term isomers. And constitutional isomers are isomers that have a different atom connectivity. And that's exactly what we have here. It's kind of the effect of breaking off one of these carbon groups and connecting it to a different position to get the isomer. All right, so let's work through an example where we draw the 3 C5H12 constitutional isomers. So carbon 4, there were just 2. Carbon 5, there happens to be 3. And as you increase the number of carbons, you increase the number of constitutional isomers almost exponentially. So what I recommend doing is just pausing the video for a second and see if you can draw the 3 possibilities. Well, we can start with the simplest, where we have just the 5 carbon chain, which is one you already know. This is pentane. But then we can think about how we might rearrange the carbon atoms in the structure. So to provide us a reference point, I'm actually going to highlight 3 carbon atoms in the structure. That's going to be our consistent reference point. And then the other 2 carbons, just so we can refer to them, I'm going to give 1 carbon a green dot, 1 carbon a blue dot. So now let's say, well, what if we take this carbon group with the blue dot and maybe we move it to this carbon? So if we do that, I still have the 3 carbons I highlighted in red, my green carbon here, and there's different places you could put this carbon. I've just decided maybe I'll attach it right here. That gives me a new molecule. Right, this is an isomer of pentane. This one happens to be called isopentane. So now you can imagine how you might move this carbon with the green dot. And be aware, you could move it and end up with an identical structure. So Let's say I took this carbon and moved it over here to the end. Once I do that, I end up with the same molecule. I have a 4-carbon chain with a branch on the second carbon over. Here I still have a 4-carbon chain with a branch on the second carbon over. So I didn't make an isomer, I just redrew isopentane. So when you're drawing isomers, you want to make sure you're actually making something new. So what I could do to make something new is, if I break this carbon with the green dot off, here's my base. Here's the carbon with the blue dot. Maybe I attach this green carbon right here. Now I have a different connectivity. There's 4 carbons all coming off of this central carbon atom. So this is a new isomer of pentane. This one was given the name neopentane. And that name represents neo for new, a new isomer of pentane. The only issue becomes, as we increase the number of carbon atoms, the number of isomers is going to increase. And it becomes increasingly hard to give these names to remember. So what we're going to talk about here in just a bit is a systematic way to name alkanes.